Okay, we will solve problem number 23 and 24 from Hall and Knight Higher Algebra chapter 4. Find the sum of 15 terms of the series whose nth term is 4n plus 1. Okay, so we are given that the nth term is 4n plus 1. What is the first term? First term is 4 plus 1, 5. What is the second term? Second term is 4 times 2 is 8 plus 1 is 9. Third term is 4 times 3 plus 1 is 13. So we can see that this is an arithmetic progression, right? 5 plus 4 is 9, 9 plus 4 is 13. And also we know that 4n plus 1 can be written as 4 into n minus 1 plus, if you have minus 4 here, you have to add plus 4 and you have plus 1 here. So this can be written as 5 plus 4 times n minus 1. Now this is a form of an AP where the first term is 5, the common difference is 4, and the nth term is 5 plus n minus 1 times 4, right? And we have to simply find the sum of the 15 terms of this AP. So what will be the 15th term? 15th term will be 5 plus 14 into 4. This is the 15th term. Okay. So this is equal to 14 times 4 is 56. 56 plus 5 is 61. So this is the 15th term. What is the first term? First term is 5. So what is sum of 15 terms? It is 15 divided by 2 into 5 plus 61. So this is 61 plus 5 is 66. So 2 times 33, and you get 15 times 3 is 45, 495, right? So this is problem number 23. Let us look at problem number 24. Problem number 24 is, again, we have to find the sum of 35 terms of the series whose pth term is p divided by 7 plus 2. So if pth term is p by 7 plus 2, we can write this as p minus 1 times 1 by 7 plus 1 by 7 plus 2. So this becomes 15 by 7 plus p minus 1 times 1 by 7. So we know that a is 15 by 7 and common difference is 1 by 7. So we can simply find the sum of 35 terms. Sum of 35 terms will be equal to 35 divided by 2 times 2a. 2a is 30 by 7 plus 35 minus 1 is 34, and the common difference is 1 by 7, right? So this is equal to 35 by 2 into 64 by 7 . So this is 160, right? Now let us look at problem number 25 and 26. Problem number 25 is very similar to problem number 24. They are asking you to find the sum of p terms of the series whose nth term is n by a plus b, right? So, nth term is equal to n by a plus b. We can write this as n minus 1 by a plus 1 by a plus b. This is equal to b plus 1 by a. So, this is the first term plus n minus 1, and what is the common difference? Common difference is 1 by a, right. So, this is the first term and this is the common difference, right. Now, we have to simply find the sum of p terms. So, sum of p terms will be equal to p by 2 times p by 2 times 2 times b plus 1 by a plus p minus 1 into 1 by a, and you can simplify this. This will be equal to p by 2 times 2b plus 2 by a plus p by a minus 1 by a is equal to p by 2 plus 2 by a minus 1 by a is 1 by a, 2b plus 1 by a plus p by a, right. So, this is problem number 25, and problem number 26 is we have to find the sum of this series. Okay. Now, what we can write this term as? This term is 2a minus 1 by a, and similarly, what is this term? This term is 6a minus 5 by a, right. So, what we have to find is we have to find 2a minus 1 by a plus 4a minus 3 by a plus 6a minus 5 by a. Now, you can already see that this is a arithmetic progression, but I will solve this problem a little differently so that you can see an alternate way to approach this problem. You have to do this up to n terms. Okay. Now, what we can do is, this is s. So, we can write s is equal to 2a plus 4a, right, 2a plus 4a plus 6a plus 6a and so on. What will be the nth term, nth similar term? Okay, it is 2a, 4a, 6a, so it will be equal to 2 times na, right. I hope this is clear. Minus, let us say minus 1 by a, okay, times 1, so this is minus 1 by a, plus 3, so this is minus 3 by a, plus 5, so this is minus 5 by a, and similarly up to n terms. So nth term will be 2n minus 1, right. Now if you take 2a common, so this is equal to 2a, and you get 1 plus 2 plus 3 plus n minus 1 by a into 1 plus 3 plus 5 up to plus 2n minus 1. Now if you remember problem number 17 from this chapter, we have already solved this sequences, right. S is equal to 2a times, this is the sum of n natural numbers. So sum of n natural number is n into n plus 1 divided by 2 minus 1 by a, this is sum of n odd numbers, this is simply n square, right. So this 2 cancels and you get S is equal to a times n plus 1 minus n square by a. So this is the sum of the series that is asked in problem number 26.